Hello everyone, this is a great pleasure for me to present my research in front of such distinguished scholars. My name is Aziz Nasriddinov and I'm an associate professor in the Department of Computer Science at Chungbok National University. The Chungbok National University is located in South Korea, and today I will make a presentation for a topic called Application of Mobile Computer Vision for Dance Learning. Sadly, because of the pandemic caused by COVID-19, I cannot meet with you in person and get involved in live discussions. That would be a lot of fun, in fact. So, if you have any questions or ideas for cooperation related to this presentation, I'd greatly appreciate it if you could send me an email to the following address. So this slide demonstrates the table of content. Since I have only 15 minutes for presentation, I try to make it as short as I can. So first, in introduction, I will describe the background for our research, the problems of related studies, and the goals of our research. Next, I will explain how to perform a dance pose evaluation using mobile computer vision. So the method described in this presentation contains of 3 steps, and I'm going to explain each step in detail. And moreover, I will describe the results of the application of mobile computer vision for dance learning. So we have performed detailed experiments which demonstrate the effectiveness of the proposed methodology. So in the end, we'll have a conclusion and I will highlight the future work. So first, in the background, I believe that you all agree with me that recently K-pop has become very popular around the world. So with many K-pop stars hitting the top places in Billboard charts, these days K-pop received enormous amount of attention. So for example, Twitter shared a report on K-pop Twitter statistics and announced that there were a total of 6.1 billion keyword-related tweets in the past year, and I believe that is a huge amount, right? And from this figure, we can all see that K-pop bands like BTS or EXO or others have become a worldwide brands. So we all like K-pop bands not only because of their beautiful songs, but also for their fancy dance movements, right? So with the popularity of K-pop, the number of people learning how to dance through various video sharing platforms like YouTube or TikTok, right, has drastically increased. So for example, in figure 2, so we can see that people organize various challenges through TikTok to follow the movements of their favorite K-pop stars, right? So, but how do we normally learn how to dance? So we usually go to dance learning schools and hire some personal teachers, professional dance players, and learn how to dance with them, right? However, due to the pandemic caused by COVID-19, many people do not often go out, right? So moreover, due to the busy life of the young generation, especially in Korea, it's difficult to invest a certain amount of time for visiting the dance learning schools and to study with the teachers. So recently, we use various applications that replace the traditional way of learning how to dance with the teachers. So these applications we can install in our home and learn how to dance from those applications. And this brings us more flexibility in staying home and learning whatever we want, whenever we want, right? So in the case of learning, however, in this case, in the case of learning to dance individually, there is a problem that it's difficult to obtain the objective feedback. And I believe that you will agree with me on that one too. Why? Because when we learn with the teacher, a teacher can fix our movements, right? So if we make a mistake, then the teacher can tell, okay, we'll have to lower your shoulder, right? And so on. But in case of learning individually, so we always have a problem of obtaining the objective feedback. And this is going to be the motivation for our research. So there are several dance learning applications that use 3D joint information. So we investigated several of these research, and we found that most of the current research perform dance evaluation using Kinect. So they obtain a joint information of the teacher using Kinect, and then they obtain the joint information of student using Kinect. So, and then they compare it, right? And if there are any kind of differences in the movement, then they output the feedback. However, it's difficult to get the feedback without evaluation of exact pose. So in other words, it's difficult to get the feedback without the evaluation of exact position or angle of joints. And besides, considering that these methods require special equipment like Kinect or other wearable devices, they haven't been widely used for real-life dance learnings, right? So one of the biggest disadvantages of Kinect is that they're kind of difficult to use. You cannot bring Kinect to the other place and to perform the dance learning with your friends, right? I mean, you can do that, but it's kind of bothersome, right? So the first thing that comes to our mind when we talk about the flexibility and that doesn't have that kind of restrictions caused by the Kinect is the smartphone, right? A smartphone is all the time beside you, right? And recently, the smartphone cameras have become so powerful that you can perform the mobile computer vision right in your phone, right? So the goals of this research is to propose a new method to compare and evaluate the teacher and students' dance poses through we call AI-based pose estimation. So obtain it from the 2D camera of a smartphone. So instead of the 3D information, we use the 2D camera of the smartphone. So we propose a combination of methods that solve several problems associated with the pose evaluation specifically. So we will try to rectify the different body ratios and compare the position and angle of joints. So experiments on a smartphone with a real world dataset showed that we could estimate the dance pose more accurately and provide the feedbacks to the students, right, in a real time. So that means everything works in a real time. So the process of evaluating the dance pose using a smartphone contains of the following 3 steps that you see in a figure 4. So we propose a very straightforward and very simple method to compare, to correctly evaluate the dance poses. So for that, we have 3 steps. In the first step, we perform the joint position similarity evaluation. In the next step, we perform the joint angular similarity evaluation. Okay, in the third step, we perform the position and angle similarity evaluation. It's going to be here. So let me describe of each method, of each step in detail. The first, so the joint position similarity evaluation, to compare the joint positions of a teacher T and the student S, we first rectify the body different body ratios. So guys, I believe that you agree with me that there could be the situation when the size of a teacher or the height of the teacher is bigger than the height of the student. So in those cases, we'll have to first rectify the body ratios. And for that, we use the method called the partial affine transformation. So we just call it as the p-affine. So the p-affine transforms the 6 body parts. So the 6 body parts are the head. So it's a right arm and the left arm, torso, left leg, and the right leg. So that means we transform these 6 body parts of S into the same position and the ratios as the T. So the position of each T and the transformed student's joints is then evaluated through the method called object keypoint similarity. So we shortly call it as the OKS, and then we obtain the final joint position similarity scores. So once again, the first step, it's going to be the body transformation. So that means to rectify the different body ratios, and then comparing the joint positions. So further, the joint angular similarity of dance pose is evaluated through their angle differences. So for that, we selected the 8 joints. So that means for checking the angle differences, we selected the 8 joints. So this is the left and right shoulders, left and right elbows, left and right hips, and left and right knees. So we believe that these poses, these joints are the most mostly used in the dance. So the final joint angular similarity score was evaluated using the threshold that considers the level of the user. So for example, for the beginners, we can put the threshold of the 45 degrees, right? So for the intermediate, we can put the 30 degrees, and for the expert, we can put the 15 degrees. So that means experts will have to do their best in order to have an error rate in the 15 degrees. So in the end, the position and angle similarity is evaluated. So here the weights are applied to the joint position similarity score and the joint angular similarity score by reflecting the dance teacher's opinion. So in other words, that the dance teachers would tell which action, right, or which, let's say, movement is more important. That's why, based on the dance teacher's opinion, we decide the weights. And here the final position and angle similarity is obtained by summing those 2 values. So we saw that our method is pretty straightforward, and for some of you it may seem a little bit simple, but we performed extensive evaluation to show the effectiveness of the proposed method. So for that, we first developed an actual dance learning application on an iPhone 11 Pro Max and checked the accuracy and the timelines of feedback. So you see from the figure 6, we can see that the structure of AI-based dance learning application for the empirical experiments. From the server, we receive the teacher's dance video, and we transform this video, the teacher's movements, into the 2 joint information. From the camera of mobile phone, we receive the student's 2D information. So here the PIF-POF and the TensorFlow's pose network used to perform the teacher's and the student's pose estimation. So from this video, you can see the actual the screen composition of the actual application for the experimental for the experiments. So you see that we have a professional teacher on the background, and we have a student who is who is trying to follow the movements, right? So from here you can see that we have the feedback. It's like a good, bad, or middle. So we have the overall score, which is generated through the evaluation of the positions of the angles of the joints and the angular similarity of the joints, right? So if I show you again, you see that it shows you in the real time it works, right? Right. So for the experiments, 5 scenarios are tested on 4 methods. So these 5 scenarios are, first, in the first scenario, the angle and body ratios are the same, but only the joint position is different. In the second scenario, so the angle is the same, but the ratios of the body and the joint positions are different. So the body ratios are the same in the third scenario, but the angle joints position are different. So in the fourth scenario, so different people perform the different dances, and in the last one, the evaluation based on the real world dataset were performed. So we applied those 5 scenarios into our 4 methods. So the first one will be simply compare. In the second method, it will be normalize and compare the body ratios based on the torso size. In the third method, we apply only the general affine transformation. So in the last step, it's going to be our method. And from the experiments, you can see from this table the result of the experiments. So the D method is our method. So you can see that it outperforms the competing methods in all 5 scenarios. You see that for almost all of the cases, we actually received the higher accuracies. So as for timeliness, the PA similarity, the position and angle similarity, can obtain within a very short time. So in other words, it was from 0.3 milliseconds to 0.79 milliseconds per frame, which indicates that you can use this application for the real life. So in a conclusion, we have proposed a new method for dance pose evaluation for dance learning application using the smartphone. So instead of Kinect, which are difficult to use, we use more flexible smartphones. The proposed method enables us to perform a more detailed analysis of the dance pose by evaluating the position and angle of joints simultaneously. Through comparative experiments conducted on the various scenarios included in the real-world dataset, it was proved that the proposed method sufficiently considered the various body parts. It was also shown that the pose evaluation is also possible on a smartphone in real time. So we said that it achieves a very high frame rate, right? So that's why we can use it in a real time. The students can be given a more accurate feedback related to the dance pose in a real time. So since it was a very short presentation, I tried to hide all the technical details of my research. So if you are interested, it was already published as a paper in one of the prestigious conference called the UbiComp in 2020. So if you are interested, you can search this paper on internet and you can see the details of the paper. This research was also supported by the Ministry of Trade and Industry and Energy of South Korea for the grant called the Development of Korean Wave Convergence Service for AI-based motion evaluation and learning technologies. So these are the references, and thank you for your attention. So in the end of my presentation, I would like to tell. So many of you might have a question related to to my research. So for example, there is a very obvious question like, how do you deal with the occlusions, right? Or how do you deal with the cases when the student, for example, or the teacher turns and the joint information is not obtained correctly? So for those situations, we also have now, we are in the final stage of developing the solution for those cases. So if you have questions related to those problems, I can answer you through email. So once again, it was a great pleasure to present my research in front of such a great scholars. So if you have any questions, you can go ahead and send me an email. Thank you so much.